Good afternoon. Many of you guys missed today's lesson, so I thought I'd do a couple of example problems and then post them online for you. So today we went over solving radical equations. Our goal is to be able to solve these equations that contain radicals or rational exponents. So in the first example, solving a simple radical equation, we're just going to solve this just like we would any other equation. So the first thing I would do here is subtract 2 from both sides. So when we subtract 2 from both sides, we get the cubed root of x equals negative 2. So now I need to get rid of the cubed root, right? So the opposite of taking the third root of something is raising it to the third power. So I'm going to say the third root of x raised to the third power is going to equal negative 2 raised to the third power. So since the third root and the third power are inverse operations of each other, I'm left with x on this side, and negative 2 to the third power is negative 8. So you do the same thing for the other ones in this section. So for c, since we have this to the have the fourth root of x, we would raise both sides to the fourth power. So we say the fourth root of x raised to the fourth power equals the third root, or equals 3 raised to the fourth power. So that would give me x equals 81. So let's look at d. So for d, we would subtract 4 first. So that would give us 3 times the quantity x minus 1 to the 2/3 equals 48. We would then divide both sides by 3. So we'd get x minus 1 raised to the 2/3 equals 16. So now to get rid of the 2/3 power, so we would have to cube it and then take the square root of it. So we're just going to go ahead and do that in one step by multiplying or raising both sides to the 3/2 power. So we're going to multiply by the reciprocal. So we're going to say x minus 1 raised to the 2/3, we're going to raise that to the 3/2. And that's going to equal 16 raised to the 3/2. So when we have a power raised to a power, remember we multiply, so that's going to give us 6 over 6, which is 1, so that reduces away. So we're left with x minus 1 on this side. And then for 16, if we was to take the square root of 16, that would be 4, and then take 4 and raise it to the third power. That would give us 64. And so then the last step would be to add 1 to both sides, and so we would get x equals 65. So let's look at the next section. For example 2, solving an equation with a rational exponent. So we're going to do exactly the same thing we did in the first example, except instead of giving it to us in the radical form, they're giving it to us as a rational exponent. So the first thing I'm going to do for this first one is divide by 2. So I get x to the 1/2 power equals 5. Well, x to the 1/2 power is the same thing as saying the square root of x. So I'm going to raise both sides to the second power, so I'm going to square it. So I'm going to say x to the 1/2 power squared equals 5 squared. Well, once again, a power raised to a power, you multiply, so you get 2 over 2, which is 1. So we're left with x on this side. And then 5 squared is 25. So I'd like to go through e, and then we'll move to the back side. So for e, the first thing we're going to want to do is get rid of this negative sign here. So we're going to divide both sides by negative 1. So on this side we have negative 1 over negative 1, which cancels, reduces to 1. So we have x minus 3 on this side, And over here we have x divided by negative 1, which is negative x, and then negative 5 divided by negative 1, which is positive 5. So remember, we have to distribute that negative 1 to both terms. So now I have the square root of this. So to get rid of the square root, I'm going to square both sides. So I'm going to take both sides and I'm going to square it. So now that leaves me with x minus 3 on this side. And then over here, I have x, or negative x plus 5 times negative x plus 5. So we would have to use the distributive property and then combine like terms to simplify this side. So we have x minus 3 over here, and have negative x times negative x, which is x squared.